Today we are going to learn remaining problem in a practice set 5.1. आज आपण प्रॅक्टिस सेट 5.1 मधील उर्वरित प्रॉब्लेमचा अभ्यास करूया. Problem number 3 in a practice set 5.1. Find the coordinate of a point on x-axis which is equidistant from point A minus 3, 4 and point B 1 minus 4. x अक्षावरील बिंदू दिलेला बिंदू ए आणि बी पासून समदूर असेल तर x अक्षावरील बिंदूचे निर्देशक लिहा. Solution: let the point P on x-axis, its coordinate, x coordinate is a x and y coordinate is 0. On y-axis, be equidistant from coordinate point A minus 3, 4 and B 1 minus 4. Therefore, point P is equidistant from point A and B, hence PA is equal to PB. Squaring on both sides, then we get PA square is equal to PB square. First to find PA. The point P, coordinate x0, consider as x1, y1. Therefore, x1 is equal to x, y1 is equal to 0. And point coordinate of point A minus 3, 4 consider as x2, y2. Therefore, x2 is equal to minus 3, y2 is equal to 4. By using distance formula to find PA is equal to in square root x2 minus x1 bracket square plus y2 minus y1 square. Squaring on both sides, then we get PA square is equal to in a first bracket x2 minus x1 bracket square plus y2 minus y1 bracket square. Substitute the value. Here x2 is equal to minus 3 minus x bracket square plus 4 minus 0 bracket square. Minus 3 minus x means a minus b bracket square. By using expansion formula, a square minus 2ab plus b square. A is a minus 3, b is a x. Minus 3 square minus 2 into minus 3 multiply x plus x square plus 4 square. Minus 3 square is a 9. Minus plus 3 to the 6x plus x square. 4 square is 16. 16 plus 9 is equal to 25. PA square is equal to 25 plus 6x plus x square. And to find PB square, for PB, the point Px0 consider as x1, y1. Therefore, x1 is equal to x, y1 is equal to 0. And B of coordinate 1 minus 4 consider as x2, y2. Therefore, x2 is equal to 1, y2 is equal to minus 4. By using distance formula, PB square is equal to x2 minus x1 square plus y2 minus y1 bracket square. Substitute the value. 1 minus x bracket square plus minus 4 minus 0 bracket square. PB square is equal to 1 minus x square plus minus 4 square. By using expansion formula, a minus b bracket square. 1 square minus 2 multiply 1 multiply x plus x square minus 4 square is a plus 16. Therefore, 1 minus 2x plus x square plus 16. 16 plus 1 is a 17. 17 minus 2x plus x square. This is a Pn square. We know that the PS square is equal to PB square. Equating this value, PS square is equal to 25 plus 6x plus x square is equal to PB square is equal to 17 minus 2x plus x square. Like terms take one side. Here plus 6x minus 2x goes on LHS side, then you get plus. Here's a plus x square goes on LHS side, then you get minus is equal to 17 plus 25 goes on RHS side, then you get minus 25. Plus x square minus x square get cancelled. 6x plus 2x is a 8x is equal to 17 minus 25 is equal to minus 8. 8x is equal to minus 8. 8 goes down RHS side, then we get divide x is equal to minus 8 upon 8. Therefore, 8 ones are 8, x is equal to minus 1. Therefore, the coordinate of point on x-axis X coordinate is a x value minus 1 0, which is equidistance from given point A and B. Problem number 4 in practice set 5.1. Verify that points P minus 2 2, Q 2 2 and R 2 7 are vertices of right angle triangle. दिलेले बिंदू पी क्यू आर हे काटकोन त्रिकोणाचे शिरोबिंदू आहेत हे सिद्ध करा. We know that in a right angle triangle, if square of largest side is equal to sum of square of remaining two sides, then given triangle is right angle triangle. पायथागोरसच्या प्रमाणानुसार काटकोन त्रिकोणामध्ये सर्वात मोठ्या बाजूचा वर्ग हा उरलेल्या दोन बाजूच्या वर्गाच्या बेरजे एवढा असेल तर तो त्रिकोण काटकोन त्रिकोण असेल. First, we will find distance PQ, distance QR and distance PR. प्रथम आपण ही distance काढून घेऊया. First to find distance PQ, that is side PQ. P, the coordinate of point P minus 2 2. Consider as x1 y1, therefore x1 is equal to minus 2, y1 is equal to 2. The coordinate of point Q 2 2, consider as x2 y2, therefore x2 is equal to 2, y2 is equal to 2. By using distance formula, PQ is equal to in square root x2 minus x1 square plus y2 minus y1 square. PQ is equal to 2 minus of minus 2 bracket square plus 2 minus 2 bracket square. Minus minus plus 2 2 is a 4 square plus 2 minus 2 is a 0, 4 square is a 16 plus 0. Therefore PQ is equal to in square root 16, 16 square root is a 4, therefore PQ is equal to 4. This is the length of side PQ. We get equation number 1. Similarly, to find distance QR, that is side QR. Coordinate of point Q 2 2, consider as x1 y1, therefore x1 is equal to 2, y1 is equal to 2. Point R 2 7, consider as x2 y2, therefore x2 is equal to 2, y2 is equal to 7. By using distance formula, QR is equal to in square root x2 minus x1 bracket square plus y2 minus y1 bracket square. QR is equal to in square root 2 minus 2 bracket square plus 7 minus 2 bracket square. 2 minus 2 is a 0 square plus 7 minus 2 is a 5 square. 0 square is a 0, 5 square is a 25. QR is equal to in square root 25. Square root of 25 is a 5. Therefore, distance QR or length of side QR is equal to 5. We get equation number 2. Then next, to find distance PR or length of side of triangle PR. Coordinate of point P minus 2 2, consider x1 y1, and coordinate of point R 2 7, consider as x2 y2. Therefore, by using distance formula, PR is equal to in a square root x2 minus x1 square plus y2 minus y1 square. Therefore, PR is equal to, substitute the value, 2 minus of minus 2 bracket square plus 7 minus 2 bracket square. Here 2 minus minus plus 2 plus 2 is a 4 square, 7 minus 2 is a 5 square. 4 square is a 16 plus 5 square is a 25. PR is equal to in square root 16 plus 25. Therefore, PR is equal to in a square root 41. We get equation number 3. In a triangle PQR, this is a triangle PQR. The largest side is a PQ having length square root 39. Remaining two side PQ is equal to 4 and QR is equal to 5. त्रिकोण PQR मध्ये सर्वात मोठी बाजू PR आहे वर्गमुळात 39 PQ ची लांबी 4 आहे, QR ची लांबी 5 आहे. By using converse of Pythagoras theorem, the sum of two sides PQ square plus QR squared 4 square plus 5 square 16 plus 25 is equal to 41. Therefore, PQ square plus QR square is equal to 41, equation number 1. And square of largest side PR is equal to square root 41. Square root of 41 of square is a 41. Therefore, PR square is equal to 41. From equation 1 and 2, PQ square plus QR square is equal to PR square. Hence, by using converse of Pythagoras theorem, sum square of largest side is equal to sum of square of remaining two side, then such triangle is right angle triangle. Therefore, points P minus 2 2, Q 2 2 and R 2 7 are vertices of right angle triangle. Problem number 5. Show that points P 2 minus 2, Q 7 3, R 11 minus 1 and S 6 minus 6 are vertices of parallelogram. दिलेले बिंदू P, Q, R आणि S हे समांतरभुज चौकोनाचे शिरोबिंदू आहेत हे दाखवा. Solution of this problem. In a quadrilateral, if opposite sides are equal and parallel, then it is said to be parallelogram. ज्या चौकोनाच्या सम्मुख बाजू एकरूप आहेत आणि समांतर आहेत अशा चौकोनाला आपण समांतरभुज चौकोन म्हणतो. पी क्यू आर एस शिरोबिंदू असणाऱ्या चौकोनाच्या सम्मुख बाजू एकरूप दाखवूया. We will find distance PQ, distance QR, distance RS and distance PS. First to find distance PQ means side PQ. The coordinate of point P 2 minus 2 consider as x1 y1. Therefore x2 is equal to 2, y1 is equal to minus 2. The coordinate of point Q 7 3 consider as x2 y2. Therefore x2 is equal to 7 and y2 is equal to 3. By using distance formula, PQ is equal to in square root x2 minus x1 square plus y2 minus y1 square. Substitute the value. PQ is equal to in square root 7 minus 2 square plus 3 minus of minus 2 bracket square. PQ is equal to in square root 7 minus 2 is a 5 square plus 3 minus minus plus 2. 3 plus 2 is a 5 square. 5 square is a 25 plus 25. In a square root, PQ is equal to in square root 50. 50 we can write factorize 25 multiplied 2. Taking square root of 25, 5 square root 2. Therefore, PQ is equal to 5 square root 2. This is the distance PQ or length of side PQ. The next to find distance QR or length of side QR. For Q 7 3 consider as x1 y1 and point R 11 minus 2 1 consider as x2 y2. Therefore x2 is equal to 11, y2 is equal to minus 1. QR is equal to in a square root x2 minus x1 square plus y2 minus y1 square. Substitute the value. QR is equal to in square root 11 minus 7 bracket square plus minus 1 minus 3 bracket square. QR is equal to in square root 11 minus 7 is a 4 square plus minus 4 square. In a square root 16 plus 16 is equal to in square root 16 multiplied 2. Taking square root of 16 is a 4. 4 square root 2 is the distance QR or length of side QR. Similarly, to find distance RS or length of side RS. For point R11 minus 1, consider as x1 y1. Point S6 minus 6, consider as x2 y2. By using distance formula, RS is equal to in square root x2 minus x1 bracket square plus y2 minus y1 bracket square. RS is equal to in square root 6 minus 11 bracket square plus minus 6 minus of minus 1 bracket square. RS is equal to in square root 6 minus 11 is a minus 5 square plus minus 6 minus minus plus 1. Minus 6 plus 1 is a minus 5. RS is equal to in square root 5 square is a 25 minus 5 square is a 25. RS is equal to in square root 50. 50 we can factorize 25 multiplied 2 is a 5 square root 2. We get equation number 3. And last to find the side PS. For point P 2 minus 2, consider as x1 y1, and point S 6 minus 6, consider as x2 y2. By using distance formula, PS is equal to in square root x2 minus x1 bracket square plus y2 minus y1 bracket square. PS is equal to in square root 6 minus 2 bracket square plus minus 6 minus of minus 2 bracket square. PS is equal to in square root 4 square plus minus 6 plus 2 bracket square. 4 square is 16 minus 4 square is 16. 16 plus 16. Therefore, PS is equal to square root 16 multiplied 2, 4 square root 2. We get equation number 4. From equation 1, 2, 3 and 4, PQ is equal to SR and PS is equal to QR. In a quadrilateral PQRS, PQ is equal to SR and PS is equal to QR. Therefore, in a quadrilateral PQRS, opposite sides are equal length. Hence, they are parallel. Therefore, it is a parallelogram. Therefore, given points P, Q, R and S are the vertices of parallelogram.